Hello there. So let's get started. I can say to you right now that even now the point will be quite obvious, and I will need to explain a little bit of chemistry to everyone's watching. So let's start with the video. Glad to be here. So,
Okay, polysaccharides.
of course, he start with drawing without saying anything. So I will talk over it. People laughing.
I want to take two of these and couple them together just to make a diamond. That's it, just to make a diamond. Make a disaccharide of glucose.
Dimer, so a couple of molecule of sugar, basically. A sugar composed by two elements. I will explain a little. That's quite a bad point from Tour, and I will explain why.
What we've established here is that in this coupling, this is down. This is the alpha configuration at that center. We've also established that this hydroxyl did not participate. This hydroxyl did not participate. This hydroxyl did not participate. In order to do this biologically, not prebiotically, but biologically, you have to use an enzyme that has about a thousand amino acids in it.
True, but it's not relevant, and I will explain to you why in a little bit.
So the probability of that forming randomly would be 20 to the 1,000th. I mean, it's just a crazy big number. If something's bigger than 10 to the 50th, you don't have enough time in the universe. Here, you wouldn't have enough time in a billion universes. Is there any chemistry that you can show me that's prebiotically relevant that would do this coupling? And you will say, oh, I argue that only enzymes can do this. You don't have enzymes because you couldn't make them here. You couldn't make them there. No enzymes. You're lost. You already established you don't have enzymes. There's no enzymes.
So, I think that's Dave here in the first point did his job in a good way, but Tour is completely wrong. Why? First of all, polysaccharides, they are sugars. We are talking about sugar. I will show you what's sugar because I think it's important to do so. So these are sugars. Why he did write on the board in a different way? Because you can represent sugars in two ways, basically. The linear way, like that, or in the cyclic form. And that's the way he did. They are just sugar. Why it's not important for the discussion? Because sugar are important for us to eat, basically, to breed, to make the cell do its work, to produce energy. But in the prebiotic earth, that kind of thing is not that important. You can get energy from the environment, eat, basically, and you can also burn, eat, breed with different compounds. We can do it with proteins too, to be clear. For what I can understand, sugar is not something you need to have biogenesis. it's important right now, but not for abiogenesis. And I think I will keep this part. So yes, this point is irrelevant, basically.
Couldn't make them. You're clueless on that.
Okay,
Okay, well, I showed peptide formation and I showed RNA formation, and this entire talking point is a
When you
non-starter.
can't do it with half of the amino acids, you didn't make it with the peptides. When you
Dave is right here. This point means nothing.
can't control that 2,5 linkage that's 30 to 70% 2,5, you haven't made any functional nucleotide.
Okay,
So you
you're
don't have those two.
You're calling Shostak a liar because the functional RNA was the first two words in the title of the paper. So you are actively calling.
Remember what I told you about the title of the paper? Remember what I told you about it?
They are talking over each other. Not very fond of the liar, but yeah, here is right. The point is nonsense.
A bunch of hype. That's why I said, Mr. Farina, show us the data. Show us the data. And you said you read the paper and you couldn't find
I showed you a bunch of
couldn't find
papers
in there how much 2,5 he has.
You just start
Shostak is very careful. He would supply that data.
The data, we can survive burning our proteins right now with our cells. More simple organisms do not even need this kind of compounds. That's my data.
Okay, James. So check it out. You're completely unhinged and wrong about everything we said about polypeptides and polynucleotides. However, let's take that out of the equation, okay? Because you said you're going to give me all the molecules, whatever you said earlier. Will you concede that this is a perfectly viable explanation for biologically relevant polysaccharides?
You only came out with that in your second series. In your first video on your first video, you said,
Yeah. We can have sugar when life is already a thing. No problem.
these just keep hooking on the end. Only when I nailed you on it did you come out in your second one and say, oh, I meant it had enzymes. Okay, and with enzymes you can get it, but you don't yet have enzymes. You don't have enzymes. That's why I put polysaccharide number 3 to show that it's
So you're wrong, and we do have enzymes, but if you'll grant me the enzymes anyway in this magical world that you've invented, where will you concede that this is a perfectly viable explanation for biologically relevant polysaccharides? Enzymes did it, just like they do today. Can you wrap it up?
Reason. Here I cannot say nothing. Very good, indeed. Maybe he will need to do all the debate like that, not just a little bit of the debate towards the end.
Your head around that, James?
Give me a minute to wrap my head
Give me a
around
minute
it.
to know what enzymes are and what they do.
Just give me
If enzymes exist, can we get biologically relevant polysaccharides? Yes or no?
Here is the enzyme.
The answer is yes.
Yes, we can.
Do this. This is the enzyme that does this. It is 98 kilodaltons. It's 20 to the 842. That's 10 to the 1094.
Yeah.
A lot of numbers, but we can get those things. If we have life, we can get there. It's not that big of a problem.
Possible scenarios. If you have anything,
To be clear, the first organism would not need sugars to survive. So you need things like that when you have macroorganisms. So animals, multicellular animals. For the first steps of life, no, you do not need anything like that.
more
Is that the enzyme that does this
10
today?
to the
Or is that the
50th.
enzyme
You don't
that
have
does
enough
4 billion
time
years
in our
ago?
universe. In 14 billion years.
Wow, big numbers! Big numbers!
Yeah,
guys.
big numbers. So this is the type of enzyme you would have to have.
So this is an enzyme that exists today.
Yes.
And is the product of 4 billion years, or however many billion years of evolution. I'm not sure when this exactly came about. is it possible that another enzyme that doesn't have this exact sequence?
The bad thing is they are not explaining the question very well. First of all, let me know in the comments if someone is interested in it. If you were able to tell that they were talking about sugars. Um, I think it was not that clear. Uh, Dave is right here, and Tour made just a bad point.
Could perform this chemistry. Yeah?
Well, let's take a look at that.
I mean, or you could just answer
Let me tell you, let's take a look at that. This is a little molecule, right? This is a little 6-carbon molecule.
Sure.
You know how much it took to make this? It takes 11 enzymes.
6. I cannot see the drawings. Maybe more. I cannot understand the last part. But yeah, some sugars do have 6 molecules of carbon, but the drawing itself, it's not 6 atom of carbon. One of the point is taken by an oxygen, and you have a tail basically to get to 6. Just to be clear, I cannot understand that drawing. Seems a little bit odd.
4 of them unique and 4 activators and these 15 steps today to make it. You're telling me on an earlier there was some enzyme that magically put this
No, you do not need to have that on the beginning. So irrelevant.
molecule together. This takes 14
You're talking about
enzymes.
a monosaccharide?
This is
James, remember Ben?
monosaccharide. Monosaccharide. This is 10 to the 65,000.
Foremost mixed sugars. Foremost reaction mixed sugars. What are you talking about? You're talking about
Because they've never been able to separate
polysaccharides.
those. They've never been able to use those sugars for anything.
What do you mean?
Because they're so contaminated. Name me one person.
First of all, you do not need even sugars to begin with. You just need something to give energy. Even the environment. Of course, we need to eat because we are too big to absorb energy. But if you want to have an example of something like that, look at the plants. They just need to take in gases and use the energy of the sun. Of course, we need to eat, but not every organism need to. Of course, plants do produce sugar, but they can use the sun energy to have those process. So not everything need to burn sugars, fat, and things like that to have energy.
Name me.
Of course, maybe you need the sugars even for some structures because they do have those kind of use right now. But for abiogenesis, I think it's not relevant.
Name me one
Of course, if I'm wrong, feel free to tell me.
person, one person that has made a stereo-controlled reaction to make glucose, stereo-controlled reaction to make glucose.
Stereo control reaction, a reaction that create a molecule with a certain arrangement, a alpha bond and not a beta. The bond the other way around, basically. Not relevant for abiogenesis. we can have that with the enzymes
glucose, and that could ever separate it from the
or some kind of catalysis. Remember that.
mess that you get.
Why would
Zero.
they? Why would
Nobody.
they have to separate it?
Nobody.
Why would they have to separate it?
You have to separate it.
Why? You have to separate it in the lab because you need to characterize it because you're a chemist.
No, because
Nature doesn't need
to
to
take
do
it on
that.
to the next step. There's so many.
Molecules that are in a mixture can't do chemistry?
What did Lee Cronin tell you? In the foremost
I don't know, he's
reactions,
not my
you get
favorite
billions,
scientist, like,
billions of compounds.
Yeah.
In seconds to hours, you get billions.
And that's why they do all this research on mineral surfaces because it's
The mineral surface didn't
the compound.
We do not need to have those sugars in particular. Why not monosaccharides? Why not simpler compounds? Why not?
The mineral surface didn't take care of it. You want to get into what Benner did?
Remember the NMR spectrum? Remember the billions of compounds?
Okay,
And the
you
NMR
want me
spectrum
to
that you
address
can't read
Benner's
because you're a
problem?
buffoon?
Here's Benner's problem. All right, you want me to address that? We'll address it. All right,
Foremost, give you
here.
I'm sorry, James. I don't know what to tell you here. You're just in denial of reality, and it's unfortunate that you cannot read.
Okay, here's Benner's reaction to make his four compounds. Here's his reaction, okay? So here he goes through this. What did he do? Here's the experimental procedure. What he did is he silated it. He silated it with this NO-bis trimethylsilyl-trifluoroSN. He silated it, he ran, and then he filtered it twice. It was filtered twice.
To be clear, they are talking about this kind of reaction, Formose reaction. And they get two sugars. It's a pretty specific thing, but it's right to show you what they are even talking about. And yeah, you can get two sugars, basically. If you need to know more, just tell me. No problem.
Before it ever got on the GC to filter out many of the things.
Because he's doing characterization, James.
No.
He has to
He's
verify what
he's
he
telling us
does.
he made four compounds. Here's the four compounds he says he made. Okay?
James,
Characterization. When you work on a compound and you need to insert some part to make a reaction happen in a specific point of the compound. You cannot just mix the ingredients just like that. You need to get in a specific point. That's basically a characterization.
do you understand?
What do you think all these other peaks are? What are all these other peaks that he's even filtered out? Now, let's even just stay at this. Let's say he just made four.
This is pathetic.
No.
You're covering for the fact that you can't read the NMR spectrum.
Here he gives his half-life. He gives the half-life of each of these compounds.
Cheap shots to tour. Fine, I think. Not done in this way will be acceptable to do so. You are not able to do so, and so fine.
Compounds on his borate glass, on his colmanite. Here's the half-life. You know what half-life means? That in a few hours, half of it is decomposed. What did it decompose into, Steve Benner? I asked Steve Benner this very question. You said it has a half-life. What did it decompose into?
And then he didn't get back to you because he's
And you know what Steve Benner said to me? You know what Steve Benner said to me? He said nothing. He answered every other question but that.
Nothing. They will break off in the smaller molecules, maybe something like glycerin or something like that. If you look at a sugar, and I can show you to you. So okay. Uh, uh, uh. Monosaccharides. So you have a sugar. First of all, we are talking about mono or disaccharides. If it's a di or polysaccharides, you will get the monosaccharide. So that's quite easy. This is glucose, the two variation. If you decompose that, you what you can get, maybe this part of the molecule will break off, or you will have some kind of attack of some kind of molecule somewhere here. The most simple thing is to have an attack here and have this part cut off, basically. So smaller molecules still able to burn, to be eaten, basically. That's what you get. For sure, you can not get nothing. It's one of the most fundamental principle of physics. You get nothing is destroyed in chemistry.
Then, so I wrote to him back in January. I tried to understand from him, how did he get that? Now, let's say he did have just 4 compounds and he made 200 mers. That would give you 10 to the 120 different RNA molecules. 10 to the 120. Remember, 10 to the 50, 10 to the 90 is the number of elemental particles in the universe.
Okay, we're
In the
moving
universe.
these numbers.
This guy made 10 to the 120 different molecules. It's totally useless. Totally useless.
Have you seen
This
this
is
one
what
by
we do.
Joyce?
We're a little bit over, so we need
Okay.
No, let's see, Dave. I already seen his points. They are not very good.
to
I'm
go
done.
to the next
All right.
line.
So, who asks this? Okay.
Is that me? All right. Let me get to my start. Okay. Okay, let's talk homochirality. Living organisms use L amino acids for proteins and D sugars for nucleic
I've
acids.
given you all the
Many-
chirality. I've given it to you.
So, yeah, chirality, as Tor is pointing, was given at the beginning of the debate. Not a very smart choice.
Yeah, this is my 2 minutes, James. Keep quiet. So first it should be noted that Dave doesn't know chemistry. Farina had to teach James the definition of homochiral. He was using it improperly. But more important,
How to lose a debate. Start insulting your opponent and keep going on. I get it, but it's a little bit too much, Dave.
James either fumbles or ignores all the research in this area. This all started when I cited a singular paper talking about stochastic crystallizations of amino acids. In his content, James deflected to another paper, complained about EE and yield for a while, and totally ignored the data in the paper, referring to this train wreck as having a field day compared with my ability to actually discuss the paper properly. If James would like, we can get him up to speed on stochastic crystallization tonight. But to give a brief overview, we know that threonine and asparagine crystallize as one enantiomer. Research has shown glutamic and aspartic acid do the same under metastable conditions, plus co-crystallization of all others in tandem with asparagine at yields and EEs James pretends aren't real. Beyond this, deracinization has been demonstrated via sublimation.
What's the problem here? You need to get to homochirality from something that's racemic. What's a racemic mixture? Basically, a mixture where you get two or more version of a molecule, like your hands, right, left hand, compounds, basically with the same components, but that they are disposed like your hands, right and left hand. You cannot superimpose those hands. So those compounds, even though they are basically they have at the same things, they are not the same, like your hands, same number of fingers, but you cannot superpose them, and they work in a different way. It's a problem, but we can solve it, and they are quite a few. Um, there are few ways that we know for solve this problem.
So even racemic crystals can become enantiopure. Donna Blackman has done a lot of work in this area, so James decided to quote mine her like crazy in his content, pretending some things she said about parity violation somehow describe homochirality in general. In reality, her review, Spoilt for Choice, from way back in 2007, already summarizes many of the ways homochirality can have come about, which means we don't know precisely how it happened, only because we know of so many feasible options. Then there is research showing how homochirality could have evolved at the polymer level rather than the monomer, but still prior to the emergence of life, and then more research discussing homochirality after the simplest life emerged. Here is a handy chart depicting all the possibilities, so there are lots of places for us to begin this discussion.
Okay, very very interesting. So let me know if you want, anyone wants a little bit closer analysis on these points. But it's very good. Here it say that monomers actually can create a chiral bias, basically a process that will get you to homochirality in a way and not in another. And they are quite interesting information if you want to know more. Problem is, this slide, there is too much on it for someone to read. Just look at it. I just read this small part. So, mm, it's not that easy. You need to simplify your information when you present that kind of information to the public. This scheme is not good for a debate, if you ask me to. Maybe write in the comments if someone wants to, of course, if you can understand what's written in there and if you can understand it.
Okay, I just want you to understand what the man has just done and he keeps doing is he's reading exactly the script from his YouTube video. He
Very good point. Not from your is YouTube video, but is reading those papers. When you prepare for a debate, you need to be a little bit more. How can I say? A little bit more nimble on your feet. Just think about it. Oh, I need to do a video. So, okay, I need to talk about polysaccharides. Very good indeed. So, yes, let me find. Not good. Those are not even notes relevant to this video. I'm doing it without a script. Maybe I need to improve that. My fault. I just prepare watching the video, doing some research on it. Aside from that, this is just me talking to you.
cannot speak chemistry
No,
on the
I
fly.
wrote this
He's
script for
reading
this
the
debate.
script from his YouTube video. That's
I mean,
exactly
I'm
what he's
not.
doing.
I wrote this for
So let me
this
answer this.
because it's 2 minutes, and I like to pack.
Look,
it
I've
in.
already given him the chirality.
I think Dave is right here. It's not his the content of his video. He did prepare not well enough, if you ask me. But it's not just a reprisal of his videos.
I gave it to him, but he has to come back to this because he's got nothing
keep
else.
saying we're
All right,
curious about
so
Holocaust,
your
so we're
article
gonna talk
spoiled
about
for
it.
choice. What you said, your exact words, they're here on the screen. You said, Mr. Farina, you said, spoiled for choice, we know of too many ways that homosexuality can have arisen to say for certain which one it was. Her own words, unquote. I got this from his YouTube video. Well, that's not what the title is. Let's read the title.
This is not a real paper, and I can tell just looking in it. It's a paper made by a Christian organization, I think. Sorry, I'm wrong. I'm wrong about that. Sorry. I did read that wrong. Sorry. That's my mistake. My bad.
With me. Spoiled for choice, assessing phase behavior models for the evolution of homochirality. He said the title was one thing and it's a totally different thing. Now, he goes on. Let's look at the paper. Let's look at the paper. Now, she says, she's giving here, she says, in this magazine, Chemistry World, which is not a mainline journal, she says they are talking about models, and she's disagreeing with them. He says they are saying it's spoiled for choice. This is not what she's talking about. She's talking about phase behaviors here. So this is the magazine she was quoting from, and then she says solution solid equilibrium, time is on our side. Dave says time is on our side means that
Irrelevant. All this part is basically irrelevant. Sorry if I had so little about it, but it's not a very helpful discussion.
time doesn't hurt us in physics. That's not what she meant. She's just using this as poetry in the sense that she says the next one, good things come to those who wait.
James, you should
Using poetry on a paper, it's not a very good idea, if you ask me.
You said, show me the data.
Yeah, I'm showing you the data. What
You
she
remember
shows,
when you couldn't
no,
read
what
this
she,
paper?
what
It was
she
really
shows
funny.
in her own paper, she shows two methods.
The problem with this debate is that it's not a real debate. They are just two guys arguing with each other without even trying to make a point. It's just a verbal fight.
A kinetic method and a thermodynamic method. The thermodynamic,
I showed you
I'm not
that.
done.
Here it's a very strange point. Thermodynamic or kinetic methods. I think that Tour does not know what he's talking about here. It makes no sense. A kinetic method, so it follow kinetics between molecules, so the way the molecules interact. Thermodynamic, dealing with thermodynamics, so energy, entropy, things like that. Usually you need to play with those kind of things if you need to get certain results, but you cannot use one or another. So here, Tour, you lost me. I think here you just made a mistake.
I'm not done. I'm not done. The thermodynamic method and the kinetic method. So here she says simply sublime. Are you going to say that that means something? No, she's just
Yes, it
using
means
the term.
something.
Now
You're
look at her
asking
references. So here's the
Like, if I was the one debating him, because it's impossible. I'm in Italy. I cannot come right now in the States, and I'm not nearly important enough to engage with someone like Tour. But I will just ask Sorry, Dr. Tour. What are you even meaning with that? Explain it to me.
Reference section.
Do
You
you know
go
what
to those
sublime means?
references,
Do you know what
your own
sublime means?
references.
Sublimation.
Of course, sublimation. That's exactly what I'm saying.
Okay.
Sublime.
Sublimation, it's not a kinetic method. I hope it's not the thing he was alluding to. I hope. I really hope.
This is what she's saying, simply sublime. It means sublimation. She's not, there's nothing deeper here.
So
You're trying to say that there's something deeper, that time is on our side. You even said in the video,
this
Jamie
is a
has to
method by
understand
which
that.
crystal.
Tour, here you lost me. And I think that I'm not the only one. I think that is using the wrong kind of terms here to define those process, and they did not point that out. Of course, I do have a language barrier. Maybe I'm the one getting this wrong, but it makes no sense to me.
Okay,
And
so
become
let's look at her papers.
You're
Let's look at the
pretending it
papers
doesn't
that she
happen.
cites. This is a review article. So we go to the exact papers. Here's her exact paper. She's using chloroform. She's using DMSO. How relevant is dimethyl sulfoxide and chloroform in a
You're
prebiotic
cherry
sense?
picking. A lot of people do this in
What do you
water.
mean I'm cherry picking? You put it under non-prebiotic conditions. You can.
The problem is why is doing so. I was using DMSO on my experiments back in my thesis work. Um, we use it for quite some. It was a solvent in my case, but I know that some people use it in a different way. So it was a solvent right there. So hmm, it's just a solvent. It's not in the reaction for what I can tell. What's the problem?
Can get synthetic chemistry to go. This is from Donna Blackman's own paper.
To be clear, a solvent is something that you use to solve a compound. These compounds, I think that they are solids, so you need something to solve them. Why not use water? I do not know, but it's not inside the reaction. So maybe is to avoid the presence of oxygen or things like that. I don't know.
This is the paper she cited in the review. The review doesn't give you detail. Then you look up
You're
the other.
cherry picking
This
one
is
aspect
wait.
of
This
the
is her
review.
review article. Let's look
Remember I
another
said
paper.
he combs the experimental section
Here
for
is
tiny
the
detail
paper.
links invalid
Here is the
study.
paper for sublimation. All right. Here's the paper she cites for sublimation. You look it up. This is the paper by Cooks. What you do is you take your material here. You take your material and you put it in this.
What does it have to do with the origin of life?
Because we're going to see if it's really prebiotically relevant. You put it in a hot tube that's at 175 degrees, and right next to it, you put a collection.
But the thing is, if uh, we are talking about sugars, why it's relevant, even if it's not prebiotically relevant. Sadie, hi, nice to see you. I was explaining why I cannot understand Tour's points here. They are ciao, è un piacere vederti. They are arguing about sugars, and first of all, they are not needed for abiogenesis, and for sure, they do not need it in the configuration they are discussing too. so I cannot get their points of both of them.
System that's at minus 78 degrees. Yeah, on an early Earth, that's really going to be possible. And so you have something 175 degrees, something at
What's
minus
this
78
study
degrees,
trying to
and it's
demonstrate?
sublime. Now,
Pre-programmed relevance?
no, wait a minute.
You're
I'm not
trying to
done. So
monopolize
she
the
says
time
it's sublime.
frame.
She
She's
says
referencing a phenomenon that exists and then applying it to ordinary life
in
research.
order for this reaction to work, she says this is her own paper.
Yeah, I cannot even understand what they are saying. They are just screaming at each other. And again, those slides are very, very bad. No one can understand what they are talking about. When you do a debate, you need to put much less information in a slide, and then you can explain and expand the topic. But when you do the slides, you need to put as little as possible with these things like papers or things like that. When I do it, usually I put the paper to show that the paper does exist, and then I present the points inside the paper and I talk about it. If you do something like that, no one will be able to read what's inside the paper. And even if they do, I think that they will be not able to understand what's inside. If you need to have a degree in chemistry, or at least something related to science, to have a shot at understanding those things. So yeah, I think that's quite bad on both sides, because it's not. Sadie, let me know if you can understand their points. I think that they are way too complex for. I do not know what's your background, but I'm guessing that you are not a chemist or a biologist. Maybe you are. If you are not, tell me if you can understand those things. Okay, that's my point. It's a bad way to do a debate. You need to explain to the people present what you are talking about at the best of your possibilities.
This is your paper, the one she cited. She says, if the first enantiomer imbalance was brought to Earth by fractionation of the organic space
Yeah,
dust
which is totally
via
possible.
sublimation, and then it landed in a pond and magically.
For example, sublimation, Sadie. I will show you what's. You know what sublimation is, for example, because it's not. It's a physical process, so not a kinetic one, like Tour was saying. Here, Tour was just wrong. Sublimation. So, transition of the substance, of the compound from solid to gas. Basically, when you have a solid and you transform it to a gas without the liquid parts. It's a phase transition. It's one of the most cryptic ones, because everyone's know about solid to liquid or liquid to solid. That's the two more known ones. Dry ice is a good example. If you ever seen the you know about dry ice, it's basically carbon dioxide, solid carbon dioxide. When you put that kind of ice, because it's basically ice, on a room temperature, it will transform to gas. just like that, from ice to gas. And it's called, in my language, dry ice. I think it's the same here. Yes, dry ice. Because it's not wet, because there is no liquid anywhere. With water, you have solid ice, then you get liquid water, and eventually you will get gas. So that's the problem with this debate. You need to explain what they are doing. They are basically taking some kind of compound, solid compound, and basically eating it to the point that is basically transitioning to gas directly without passing to the liquid form. You need to explain those things, and they do not. Both of them. It's a problem of both Dave and Tour.
Crystallized under these very
What do you
stringent
mean
chloroform
magically
GMSO
crystallized?
conditions. You couple these two crazy hard things together, then maybe
When
we could
the
get
temperature
it.
goes
There it
down,
is. That's
things
your paper.
crystallize.
That's your
Holy
paper.
smokes.
Read the paper. Look at the experimental. Look at the references.
You're just
It can't be done.
simply
It's going to be coming from one thing to the other. Can't be done.
Do you understand that we can get an angioenrichment by co-crystallization? You're going all over the place just so that you don't have to talk about the papers I'm showing you. Do you see all 12 of these amino acids are dissolving at once? It's
My pleasure. It's why I do this kind of videos. People need to know these things, because if you are not a chemist, you will not know them. Sublimation, it's something easier to know. I did explain sublimation to my students, and they have 9 years. They are 9 years older, so it's a simpler process. But of course, if you did study these kind of things back then, some years ago, of course, it's not that easy to understand what they are talking about.
stochastic, so it's random every time, and you can get very high EEs.
I've conceded it all to you, but I'm telling you, these are under amazingly stringent conditions
But they
that
aren't.
are very
But they
common.
aren't. But they aren't.
But they are. But they
No,
are. I
they
showed you
aren't.
the setup. I showed you the setup.
You showed me something that
Okay, they are not talking about sugars, but amino acids. Okay, still we do have some process that lead to homochirality. You do not need to have sublimation or things like that. I did point out stereo specific reaction, and even process like mechanical process. It was sorry, I lost that.
Donna referenced as a proof of concept that she then takes into account for origin of life research.
But you have to be.
Chromatography. I did point to those kind of things. Also, crystallization can lead to some form of homochirality also. But I think that when we are talking about abiogenesis, yes, homochirality is a problem, but I never seen the sublimation part. I would need to read all the paper to understand what's the point about that. They do not explain it the slightest.
that, no, the sublimation,
This is something that has been
look,
demonstrated
I've given you
with some
even
apparatus.
the amino acids I cited in that paper. That paper, you got 1% of the pure material.
Let's
You got
put it this way.
1%. It's a
One
very
more
difficult thing. But
statement.
anyway, I've conceded
You
that
have
point.
made a 10-hour
You
course
keep
on biochemistry,
coming back
and you
to
say
this.
homochirality, we're clueless about it.
You just said homochirality. Oh, there's the word. There's the word, homochirality. You use it over and over again in your videos until you talk to Donna Blackman. You use it over and over again. You have many references to homochirality referring to small
We
molecules.
talk about how we're clueless about homochirality all the time. That's why I showed this to show you that we're not.
All right.
Crystallization, sublimation. These are processes by which
Okay, I will stop there. Here you have a couple of minutes of the moderator asking a couple of things, but they are not relevant to the debate. Homochirality is a problem. I cannot understand why it's so important to focus on the sublimation part. I did not understand the point of that. And that's the problem about this debate. It's almost impossible, and I do a thing or two about chemistry, of course. Even for me, it's almost impossible to follow their discussion because they are pointing to a paper uh, showing only a little bit of the paper itself, and they start arguing about these things. I did watch the series. He did something new about it. I did follow the series that he had done back then, I think, a couple of years ago. Um, it was mm, it's a miss for me. I think that Tour is not an expert on this particular field of chemistry. Um, is a very good organic chemist, but when we are talking about this kind of process, they are not the typical process you use in a lab. When you are in a lab, you need to make a certain reaction happen in a certain order. So you will use, how can I put it, some process to get there. When you are in nature, you have different kind of process, and for the most part, we are getting there just in the last few years. We of course, I'm not a scientist. Scientists are uh, researching the topic, and they did found a lot about things like autocatalysis and those process, like the one I did show some videos ago, the secret one, and they are quite good. More we look into it, more we know. And if you ask my opinion, we do have a bunch of evidence that we did not have uh, a couple of years ago, maybe three. I Yes, autocatalysis. They did talk about the IUMIN in the series. I can look into it. If you can give me the video, I can review that specific topic because it's not something that simple. I think that tour do not get autocatalysis very well, if you ask me. Okay, season two. Okay, I can watch. the series and let you know. I did watch season one, so I did not look for season two, but I will love to watch into it because we are almost at the end of the debate. Basically, we have round four, another 15 minutes, and I will not look into the questions because they are not part of the debate. So, yes, I can do a review. Yes, it's fantastic. It's fantastic to be here, Sadi. It's good to talk with someone, and I do love to explain things. I did study for this kind of things, and right now I'm not using my knowledge because I do teach to children, but they are very, very young, 9 years old. I did a very good lesson about chemistry to those kids, but it was very simplified, of course, for them. It was all about a compound able to change color with the pH. And I did show them the difference in color between uh, still water and sparkling water because sparkling water is acid, pH 3. Normal water is 7 to be precise. So you can see the difference, and I did show them through an experiment. They were quite fond of it. They had a lot of fun doing it. So, Sadie, I basically at the end of the video, still an hour. That's very, very long, but I can close here. If you have a question, I will be more than happy to answer to anything you need to know. Of course, I'm not an expert, but I will try to answer to my best. Of Let's see. And if you do not have any question, I do thank you for commenting in the chat. It's wonderful to me for me to have someone in the chat. So, okay, shoot it. You have a question about RNA. Very good. Tell me. Yes, it's an hypothesis. We do not have a theory about abiogenesis. Let's be clear about that. A theory is basically a fact. Abiogenesis, we do not have any facts. And I think it's important to understand that it's almost impossible to get to a theory. Molecules do not fossilize. Fragile. If you are talking about the half-life, Tur was talking about it in this video. Yes, but it's not that easy. When you have such a reaction, how can I explain it? Chemical reaction, they are not like a computer, yes or no question. You can have a reaction that can go both ways. For the most part, all reactions are like that. We have some cases where basically it's only one way, but it's a very simple case. Usually you have a reaction with two directions. The important thing with oh, sorry. Well, if you need to conserve RNA, yes. What's the problem here? In the abiogenesis context, you just need to have RNA that's produced in a rate more fast than is degrading. And then in the next step, you can have some kind of envelope to protect the RNA, and you do not need a cell for it. We do have organisms that are alive and without a cell. Just think about viruses. And so you just need to have RNA and produce it more fast than it's degrading. Yes, you need to. Yes, it can. You just need to produce more than you lose. Because when the RNA is degrading, basically you are breaking off the polymer. I can try to show you. So, English, because of course I'm in Italy. The first language is Italian. So you have your RNA. I'll show you maybe. Okay. Something a little bit better. Okay, that's the structure of RNA. When you degrade their RNA, you are basically breaking off this bond right here. You have multiple bonds, and that's when you bond a lot of these molecules, you will get the RNA. You just need to produce more of this chain than is breaking off. In early stages of abiogenesis, you do not need a precise sequence. That kind of thing you get later. If you want to think at something that will be relevant for life in the early stages, you just think about something like a virus with an envelope and just a strand of RNA inside. And you can get those that kind of protection even with non-organic structure like crystals. So that's one of the hypotheses that we scientists, have. A form of protection, you can have an envelope made by proteins like viruses, or even inorganic structure like a crystal. So you have RNA getting inside that, and then you get further development. Of course, it will such a thing. Such structure will be not very effective, but in the early stages, you do not need a very high rate of survival of anything present. A very good example is the work of David Dreamer. He did get from organic molecules to protocells. It's possible to get to a very primitive form of cell. Lipids do form micelles, basically a sphere with nothing inside if you put them in water. So it's true that the half-life is very low. David Dreamer, I can show you. Give me a second. I think it's the guy. This guy. I do have a picture of him in some of my debates. I think that you can find the paper in the debate with Tony Maris. The debate I did on Standing for Truth about abiogenesis. Did you understand a little? Basically, RNA does tend to degrade in the condition of abiogenesis, prebiotic conditions, but you just need to have a production of RNA that's basically do a substitution of the RNA. Okay, do not worry about it. I don't know if you do have my email, but you can find it at the end of my, basically all of my presentation do end with my mail. So if you want to write me more questions, I can send you the papers. Right now, I do not have David Dreamer's paper right here because I did change PC, but I can find it and send it to you. Yes, that's the one. So Sadie, I say goodbye to you. It was really, really a pleasure to be here, and do not worry, ask me anything and I will try to answer. Of course, I'm not an expert. I am just a bachelor. I do these things for fun. And if you need someone more prepared, you need to ask the researcher himself. I think that Dave is not that good. I need to think a little bit about it. I cannot recall any chemistry aside from Dave, actually. So good night. Maybe it's evening for you, but here it's past midnight. So good night. It was a pleasure, Sadie. See you next time. It was a pleasure. It's a pleasure to help people to understand even a little. Good night. and see you soon.